Started, shall we? So this chapter here is honestly my favorite chapter of the whole year. What I like about it is that it has a lot of visualizing kind of stuff. And for me, I really enjoy that. I really enjoy that kind of trying to visualize it. This chapter here is going to be insanely easier if you show your work. So my plan is to hold you accountable to that. I'm either going to start collecting homework or do a better job of looking at homework. And if you're not showing your work on certain kinds of problems, I'll tell you as we go along, I'm going to mark you down, even if you have the right answer. Just because showing your work makes it tons easier, and if it's easier, it's way more fun. Okay, so let's just kind of hit the ground running. Perimeter area, you guys have been doing this stuff for years and years and years and years, right? Yeah. So perimeter, the abbreviation is a capital letter P. And if you had to explain perimeter to a second grader, you would just say it's the outside. The outside, or the distance, the length of the outside, something like that. So I'm going to say the distance around a figure or object or something like that. Then it'd have to be an object. So distance around a figure, distance around an object, something like that. So if we were to take this rectangle, if I know this is 3 and this is 5, I know this has to be 3. And I know this up here has to be 5. So if I wanted to get the perimeter degree, I could just do 3 plus 5 plus 3 plus 5. Yeah. 3 plus 5 plus 3 plus 5. And then you have 16. So 16 would be the perimeter, the distance around. So really you just add together all the side lengths. That is going to work for any object. Just take all the sides, add them together. Now, we can get like special equations for rectangles and squares. We'll write them down. You're welcome to use those, but most people don't, but I feel like I probably should tell you what they are anyways. Honestly, for this problem, I do 3 plus 5 and then times 2, you know, because this gets me halfway, so I double. So if you can do things like that with perimeter in your head, I'm fine with that. Otherwise, the equation for perimeter of a rectangle is P equals 2 times a lowercase b plus 2 times a lowercase h. And basically they're saying, well, double the base, 2 times the 5 would give me these two. And then 2 times the height is 2 times 3 gives me these two. So you see how it gives us the same answer? So choose whether or not you want to use it. I don't really care. For the square, I don't think I'd bother drawing this if I were you, but if I were to try to do a square, I'm going to say all the side lengths are 6. I'm going to get 6 plus 6 plus 6 plus 6, or
6 times 4.
6 times 4. For a square, it'll always be 4 times, then they just do a S for side length. Because the lengths of a square, all the sides are the same, they don't do like base and height, they just say S because they're all the same. So these two equations, honestly, I don't really use them. Maybe I use the square one. So use them, don't use them, totally up to you. Good? All right, so if we get a little bit dicier, if we start here, which way do you want to go, left or down?
Down.
That didn't make any sense, right or down? Okay, so we're going to go down. So this side here is 10 plus 2. So we have the 10 plus the 2 plus the 4 plus the 9 plus the... Uh-oh. Okay, so we need to figure out what x is, right? I'm just going to leave a blank and a little spot where I could put x in a second. Let's finish it off. But then we do, so then we had that 9. Now we need to add this 9 to it, plus the 4, plus the 2. So do you agree I got all those sides in there? All right. Now, for these, I'll draw these, and usually I kind of look at it and be like, this side here looks like it's about this length, and then this side, okay, it'd be about that length. Please don't look at it and like try to get it just by the side lengths, because it's not a perfect science. This one's actually not drawn to scale insanely well. How could we find this x? How could we find the length of that side? Go for it, Jen.
You know that whole side there to the left is 10.
Okay, so this side's 10.
Yeah, and then on the other side, there's 2 4s.
Okay.
So you know that side should be 10. What the 2?
Nice.
The x should be 2 because 8 plus 8 is. 4 plus 4 is 8, and then you need 2 to get 10.
People hear it okay?
Mm-hmm.
So the whole length here is 10. So we have 4, only 2 is left. Or 10 minus 4 gets you the 2. Perfect. And what I love about what he did is all the numbers that he used were all in the same direction. Agreed? If you're trying to find a missing side, you'll never take a vertical like the 10 and use a horizontal with a 9, unless you're going to do Pythagorean theorem or something. But it'll always be lengths that are in the same direction. All right, so we pop a 2 in here. And now you could use a calculator, or you could just work across. So 10 plus 2 is 12, plus 4 is 16, plus 9 is 25, 27, 36, 40, 42. Did anybody get something different than 42? Okay. So 42 then would be the perimeter. So I started off with this big, long diatribe about show your work, show your work. On the perimeter ones, it'd probably be, I mean, it's going to be, I think, easier if you do this, but I'm not going to hold you accountable to have an equation written down and so on. Okay for that? Most of the chapter is doing some area stuff. You're getting doing like surface areas and all kinds of things like that. I have this bookmark here with a whole bunch of equations on it. And so the ones with the asterisks by it are the ones I'm planning on you having memorized. I wouldn't stress about that. If you're showing your work like you should in the homework, you're going to know it by the time the test comes. Okay. Area. So area is the number of square units. So square units contained in something. And I don't know if I'd try to do this drawing here. I'm just trying to make a point. But if I have this side that has a length of 3, I'm going to break it up into 3 different things that all have a height now of 1. And if I have this bottom part as 4, I can cut it in the middle and cut each of those in half again. And now I have 4 things going that way. They each have a length of 1 to add up to the whole horizontal part being 4. Well, if I would count up these little squares, do you agree I'd get 12? So when we're talking about area, I'm guessing you guys know the area of a rectangle. I probably should write that in. So area of a rectangle, capital A for area always, lowercase a is acceleration. Then equals a lowercase b times a lowercase h. We're going to get capital B's later on this chapter. It'll stand for something different. But if I were to do that here, what I'm looking for in the homework is for you to actually write down a equals b times h. Then you put in 4 times 3, and you get your 12. But that's where we get these 12 square units that we're really trying to say, well, if we know this is 4 wide, if we know this is 3 high, how many of those squares total are you going to get? Fair enough? And even when you do area for a circle, you can't take a circle and nicely break it up into all square units like you can a rectangle. You're going to get these parts here that are like partials. But you take that little partial combined with this little partial, you know, and it kind of adds up to a certain number of square units. Probably with a decimal for a circle. But you okay on that? So I wouldn't stress about the square part. All right. Then area for a square. A equals, for a square, I'm just going to pick something and maybe say it's like a 5 and a 5, not drawn to scale.
A equals 5 squares.
You could say base times height, right? Because a square is a special rectangle. Or you could just say, since all those lengths are 5, you could say s squared. Yep. So that's our square equation. And the example through is kind of what I did over here. If you didn't do it, you probably can skip it. You'd be okay on those, I think. So, keep going? All right. Page 2. Our parallelogram. Parallelograms have the exact same equation as a rectangle, which is what we're going to be talking about starting tomorrow with this thing I'm excited about. Then, so if the place that messes people up is, say you get something like this that has a 10 and an 8. People will take and multiply the 10 and the 8. But is that correct?
Yeah.
No. Because what has to be true about the direction of the base and the direction of the height? They always have to have that 90-degree angle. So for these, and maybe I should have wrote it back by the rectangle, but it fits more here, that always base has to be perpendicular to height. For parallelogram equations, for triangle equations, really for rectangle and square equations, base and height are always perpendicular. And so in this case then we'd either have to find what h is with Pythagorean theorem or some other way, or maybe they also would give you like a height of 6. And again, I didn't do a good job doing this to scale. But if you were to have these for numbers, it'd be a base of 10 times a height of
6.
6. So I'd be looking for this line here. Write the equation with all the letters, put in numbers, and then give me the answer. So I'm looking for those 3 lines in your homework. And I'll keep going then. So triangle is 1/2 lowercase b times lowercase h. So 1/2 base times height. So we have that there. I'm going to skip example 5. But if we go to example 6, say, all right, so I'm going to start by writing my equation. So that's what I'm trying to get you to do. So a equals 1/2 base times height. Then we could fill in our base, which is
6.
6. Nice. Oops. So 6. So 1/2 times 6 times 4. Because you have to pick the one that's perpendicular. We have that nice right angle there. And some people look at triangles as though it's base times height divided by 2. You can keep doing that if that's what you're used to. Either way, you're going to get a 12. Or 12 square units. Maybe I should have some of these on there. If these were all inches, final answer would be 12 inches squared. Yes?
Mm-hmm.
We should start slapping some of those in there. And the base doesn't have to be the side it's sitting on. It's possible, this might totally mess up my notes. Yep. The key for what the base is, base and height, you just need to find 2 sides that are at 90-degree angles to each other. So very last one, trapezoid. For trapezoids, the equation looks probably worse than it is. It's 1/2 of the height, and then base 1 plus base 2 in parentheses. So copy this down a second. Have you guys done these before?
Yeah.
Oh, okay, so I don't need to blab. I've done all of them. Sorry, I'm going too slow then. So this is just base 1 and base 2 is not base times 1 and base times 2 is not an exponent. Those bases have to be the sides that are parallel. So my 10 and my 18 have to be the bases. Sides are parallel. So if we were to calculate this one, first step is to write the equation like we did there. Then say, all right, 1/2 of the height. Height is
4.
4. And base 1 makes no difference which one you pick. So we're going to pick 10 works for me. Plus 18. But if you did 18 plus 10, you get the same thing. Now for this here, you could punch it in your calculator exactly how it's written and let it do the math for you. If you're going to do some of it on your head, you have to first add these 2 together before you can mess with those numbers. So you have 28. So 1/2 times 4 times 28. So 2 times 28 is 56. Maybe let me throw units in this one just so I can feel a little bit more like a self-respected teacher. But if those were all feet, then my final answer would be 56 feet squared. Yep. So you'd have to be able to do 56 of those little 1 foot by 1 foot boxes inside of that whole thing. Questions?